this is where we start using limits and it gets a little bit scary, okay? You do need to know how to differentiate using first principles. It regularly comes up in exams, okay? And you need to know how to do it by hand. Once you understand this process, I'll teach you other ways of doing it and we'll get the short way of doing this stuff, all right? But you still need to understand this first. So there are a couple of things you need to know. Okay, let's start with limit as h approaches 0 of fx plus h minus fx over h. Okay, this formula is differentiation using first principles. So if you're asked to differentiate using first principles, you write this formula down. Okay, so differentiation is all about making h equal 0. So in terms of an actual function, what this means, okay, remember we talked about if we had a curve and we wanted to find the gradient at this point here, okay, we would normally put a tangent. But if we're going to do it through differentiation through first principles as h approaches 0, then what you end up with, okay, is this is x and then we add h. Alright, so that's x plus h. That puts us here. Okay? And that'll give us a line. Okay? And as we shrink this gap by making h approach 0, we actually get closer and closer and closer to the true tangent at that point. Okay? That's what this process is about. Now, keep in mind this is just a formula, it's just a process. Alright? You don't even need to worry about it. Just follow the rule. Okay? There are a couple of other things you need to know. If you differentiate y, that equals dy dx. Okay? If you differentiate fx, that equals f dash x. Alright? You'll come across them as you go through. Right? So now let's do question 1. It says find the derivative of the following using first principles. 5x minus 7. Okay, that's what we've got to differentiate via first principles. You ready? So what's fx? That's fx, isn't it? So that's just going to go here, 5x minus 7. Okay, that's this section here. We're going to divide that by h. Okay, according to our rule, we're dividing by h. But what's fx plus h? How do I put that in here? Alright, it's as simple as that. Just substitute it in. So instead of writing x, we write x plus h. Okay, now we expand and mess around and simplify. Okay, and this normally takes about half a page. So 5x plus 5h minus 7 minus 5x plus 7 divided by h. Okay, so I expanded my brackets and I also got rid of the brackets here. Okay, so I've done minus 5x and that becomes plus 7. 5 times x, 5 times h. Alright, so minus 7 plus 7, they're going to disappear. That's great. We like it when things disappear. 5x minus 5x, that's going to disappear as well. Okay, so I'm left with 5h divided by h, which is equal to 5. Congratulations, you did your first differentiation. Alright. So it's just solving using this. Now it does get trickier. Let's do a different one. Okay, so linear ones come out at a constant. Alright, because by differentiating you're finding the gradient at that point. So if you are differentiating a linear function, what's the gradient at any point along that linear graph? It's going to be the same no matter what, so it'll come out at a constant. So let's do one where it's not a constant. Okay, so part B is x squared plus 10x. Okay, we need to differentiate that using first principles. First thing you do, limit as h approaches 0 of fx plus h minus fx divided by h. Okay? Just write the formula. Now you substitute stuff in. So we know this is fx. So we're just going to put that in. X squared plus 10x goes there. Minus that. We're dividing by h. And now we're going to put x plus fx plus h in. So we've got x plus h squared plus 10x plus h. Right, now we expand and simplify. X plus h squared. Go back to your perfect square formula. What does it come out at? X squared plus 2xh plus h squared. All right, you should know that. This is where everything else comes into play. Plus 10x plus 10h minus x squared minus 10x, all divided by h. All right? So now we look for things to get rid of. And we pretty much want to get rid of anything that doesn't have a h associated with it. Okay, so that's where you start. X squared is going to disappear with this minus x squared. 10x is going to disappear with this minus 10x. So we're happy. 2xh plus h squared plus 10h divided by h. What does that look like? Can I take out a common factor of h? Yeah? Right, so I take out a common factor of h on the top, then these two disappear. So, is that right? 2x plus h plus 10. Is that our final answer? What does h approach? So we can ignore h. So my final answer is 2x plus 10. Alright. Funnily enough, yes, the gradient of a quadratic is a linear. The gradient of a cubic is a quadratic. The gradient of a quartic is a cubic. Each time you actually come one down on the polynomial scale.